Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 1 of the Murach book. And Chapter 1 is entitled An Introduction to Relational Databases and SQL. I'm not going to dwell on the objectives for the chapter. I'll leave those for you to review on your own. On slide 4, we come to a diagram of a simple client-server system. And this is probably the most simple version of system architecture that you'll see in use today. And it involves a database server, and the data is kept on a database server. In this particular architecture, all of the application code, the application code that manages the user interface, the application code that enforces the business rules, the application code that is responsible for retrieving the data from the database and sending updates to the database. All that is typically located on a single machine, the client machine. Okay, and this is this is a little bit out of date. I mean, this is kind of what people were doing in 1990 or something like that. But they were using a database server, and database servers have been popular for quite a long time. Three hardware components of a client-server system include clients. Okay, typically we're talking about a desktop computer, but in specialized cases we might be talking about a tablet, we might be talking about a smartphone. And then we have a server. In this case, the only kind of server that we have is a database server, and we have the network. Okay, and it's not really clear exactly how wide the network is in the diagram we've seen so far, but there are two kinds of network that we're typically going to find. We're going to find a local area network, which is the network usually within our business unit, that allows us to communicate with all the devices that are within the business unit and to share things like printers and file servers, and to share something like a database server like we saw on the last of the slides. We also have in this internet-enabled world wide area networks, which typically are used to connect local area networks. And these are networks that typically bridge the gap between a large number of local area networks. And in the case of the internet, which can probably be seen as the widest of wide area networks, it gives us the opportunity to connect most of the people on the planet in a networked way. And another term to know is an enterprise system. That would be an application system solution for whatever your business is. And I guess the idea here is that if we're going to call it enterprise, your business unit is probably pretty big. So in client-server systems, these are this kind of early version that we're looking at does not use the web. Okay. For instance, it could all work for within a business unit, and it could all be on one local area network. So that we have a client software typically running on a PC-ish kind of a desktop. We've got the server software typically running on a kind of a beefy PC. And then we have the SQL interface. SQL stands for Structured Query Language, and it's the database language that we're going to be learning in this course. And so in this kind of configuration, the client software comes to a point where it either needs to store or retrieve some data. And so it comes up with instructions which are expressed as SQL queries. It sends them to the database server and it gets some kind of results back. Now, if it's primarily trying to retrieve data, it's doing a query per se, and it would probably get back what we call a result set, which is a table of answers. Okay, but the other kind of things that could go on here is we could have new data that we want to insert into the database. So we could be sending SQL commands like insert that would have the new data for the database. And the results that we would be getting back would be some kind of confirmation that the insert had been successful. And the other thing that we might want to do is we might want to update the data that's already in the database. So the SQL instructions that we would be sending would be updates, in which case we would be getting back a confirmation. And then the fourth kind that we might be doing would be a delete, where we want to delete some data that we no longer need. And again, the results that we would be getting back then would be some kind of a confirmation. So the nature of the instructions that we send to the database server and the nature of the results that we get back vary depending upon the character of exactly what we're trying to do with the database. But in this very simple client-server architecture, we really have two kind of computers. We have the client computers and we have the database server. So the server software would include some kind of operating system, okay, and within it some kind of database management system, and which we typically abbreviate by calling a DBMS, Database Management System. And these days, the popular database management systems are relational database management systems. And one that's particularly popular is the one that we're going to be using in this course. It's called MySQL. The client software would be application software that would be built to run on the client machine. This software does things, it could be characterized as front-end processing in that it does really two things. It's controlling the user interaction with the application, and it's also enforcing the business rules that make up the application. And then the communication between the two uses a well-defined programming interface called an application programming interface, or as you've probably heard, an API. And because the communication is going on between a client and a database server, the API is geared towards a database functions. So it might be appropriate, for instance, to call this a data access API. So some details on the SQL interface. So the application software communicates with the DBMS by sending SQL commands through the data access API. And these SQL commands we generically call queries. Okay, I just want to point out that the only thing that's really a query in the true sense is when we are trying to send a question to get some kind of an answer back, okay, which is only a part of the commands that we send. So we send queries where we're looking for some kind of answer set to come back, or we might be inserting some data, or we might be updating some data, or we might be deleting some data. In a generic sense, we refer to all these as queries, although it's really only the first of these that's a query per se. So when the DBMS receives a query, it provides a service like returning the requested data to the client. And we often say that what it returns is a result set. And we're going to learn about relational databases that when you send a query, the result set that you get back is a little table that you're able to examine. SQL stands for Structured Query Language, which is a standard language for working with a relational database. And SQL has been the standard language of relational databases for, a good 35 years, maybe 45, a long time. So in a client-server system that we've been looking at so far, the processing is divided up between the client and the database server. Okay, and in terms of some kind of a file handling system, like communicating with files that go to the printer, or communicating with input that's coming from the keyboard. Typically that's done by the client software on the PC-like client machine. Now, on slide 10 here, we see a diagram for a more modern, more typical for today client-server application system. Okay, and it's more typical because it involves technology from the World Wide Web. Okay, now more and more we see that people like the fact that if you're using a web application, you can use a browser, and you can more or less use any kind of client machine that you want to. So if you have some kind of a desktop, you can have an Apple, you can have a Dell, you can have pretty much any kind of machine that you want to. As long as you have a standard browser, you're able to communicate with a web application. And in recent years, that's extended to other kinds of devices like tablets and smartphones. Okay, so if we're going to do that, then we don't put the entire application software suite on the client machine. What we put on the client machine is typically a browser that does a reliable and standard job of handling the user interface. And a lot of the computing is done on an application server. An application server is kind of like a web server in that a website that um, has only static pages, plain old HTML pages in CSS style sheets and a little bit of JavaScript and that kind of stuff. Well, we could have just a plain old web server there, an HTTP server. We could have the Apache server. We could have the Microsoft Internet Information Server. And all that would go on would be we would get a request from the client from the browser application, and the web server would locate the page on the web server that's associated with the request, and it would send the HTML and associated style sheets back to the client for display in the browser. Well, there are all kinds of applications that we're typically used to that do more work than that. And in particular, we're used to applications where well, the most obvious ones are where we fill out a web form. So we get a web page in the browser, and it's got a lot of form fields, and we fill out all those form fields, and there's a button. Sometimes it says go, and often it says submit, and we click on that, and then some action happens. And when that action's over, we typically get a web page back from the server. That's an HTML page, but it's not a static one. It's not one that's just been hanging around on the web server file system waiting for somebody to ask for it. It's a dynamic one. It's one that is actually created on the web server on the fly as it does the work of the application. So these kind of pages, these kinds of applications are served by web servers with more functionality that are called application servers. And there are all kinds of flavors of them. There's, let's see. There are PHP servers. There are Java EE servers. There are Microsoft .NET servers. There are more than a handful of other popular web server architectures that allow programmers to build programs that run in the web server that do the work of getting the request in from the client in the browser, turning that into the work that has to be done, and when that work's done, sending back an HTTP page, a web page as a response. What's consistent in the architecture that we have here, this three-level web architecture, is that we have a database server. So having already decided that we were going to take the application programming code and separate it from the database capabilities, we've maintained that. And so now, if we go back, previously, if I go back far enough, we had a two-level client server. We had a client and we had a database server. Now we have three-level client server where we have a client, we have an application server, and we have a database server. So the application server is the middle tier, and it's the one that gets the request from the client, does all the application code, takes all of its needs for database information and sends them off to the database server, gets the results back from the database server, and then composes a page to respond to the client, which of course goes back and gets displayed in the browser. So this is a classic three-tier client server. Here on slide 11, we see just a little bit more of the parts. They're a little bit more specific, but if this is going to work over the net, this is going to work over the web, then between the client and the web server, the request and the response are probably going across the internet. Then, between the web server and the database server, often those two servers are located in the same machine room. In fact, it's even possible that they might be both part of some big piece of hardware that is running multiple server instances. Okay, but let's assume they're two separate machines and they're in the same room. Theoretically, the database server could be across the internet yet again. Okay, so things could be pretty highly dispersed. Okay. So let's see a couple of notes. Application servers store business components. These are parts of our application programs that understand the business rules and can operate the application. And web servers store web applications and web services. So how web applications work? Well, I've talked about this a bit, so let's hope the bullets are consistent with what I've already said. A web browser on a client sends a request to a web server. That's like Apache or IIS. The web server processes the request. The web server passes any database request to the database server. The database server returns the results to the web server. The web server returns the response to the browser. So when we're using web server on this particular slide, we mean web application server. Okay, so before we go on to talk about the rest of the architecture that we're going to be dealing with in the course, I just want to talk about why what we've learned about so far is significant for what we're learning in the course and then what we're going to be doing in the course. Okay, so there are relational database users, who I would call kind of power users, who work with relational databases directly. So they, communicate with a relational database server like the MySQL server that we're going to use, and they have some kind of I would call it power user client software, something like what we're going to be using, MySQL Workbench. And they really kind of think of the database as a database. And they go to classes like this, and they learn about relational databases in detail. They learn about SQL in detail. They learn how to code the statements and all that kind of stuff. And they're expected to, as part of their job, really use relational database tools directly. hands-on. Okay, that's a very small group of the number of users who are served by relational databases. Most of the users who are going to be served by relational databases today are working in an environment more like what we saw on slide 11. They are ordinary users like you and me. They are running web applications from their browsers on their PCs and on their tablets and on their smartphones. And their interface to the application is just a typical web interface. Okay, so who does all the SQL? Well, whatever programmer is responsible for writing the application programs that run on the web server, it's part of their job. They will write SQL queries that get sent to the server and they wait for results to come back. So when we teach SQL, we really have two audiences. Audience one are the power users. Okay, the people who are really going to use SQL as a user. Really in the minority. Probably I would say maybe 20% of SQL users or 10% or even 5% are using it as SQL itself. The other audience are people who are going to become programmers of typically web applications. Okay, and these web applications are going to have to communicate with the database. And what kind of things are they going to do? Well, in the steady state, they'll be doing a lot of queries to ask for the data from the database so that they can display it on the web pages that they send back to the client in the browser. Or maybe they just got in a web form with some new information that has to go into the database. And so what they'll be sending to the database server is a bunch of inserts. Okay. Maybe what they just got from the user is information about some data that's already in the database that we want to update. So what are they going to be doing? They're going to be sending updates. So the rules for the programmers who use SQL in their programs turn out to be just about the same as the rules for the power users. So how do people typically learn this? Well, we typically don't teach you how to do the programming for the web server and how to work with SQL at the same time. So what we do in this course is we teach you to be a power user. Okay, so we're not going to have you writing web application server code. We're going to show you some at the end of the chapter and show you where the SQL is in it. But for the rest of the chapters, you're going to be a power user, and you're going to work with really two pieces of software. One, the server is going to be MySQL Community Server, and the client is going to be MySQL Workbench. By the time you're done, you'll have the information that you need to do one of two things. One, go become a power user. Okay? Don't be a programmer. Or two, be a programmer who's probably going to write programs that run on a web application server and have the information that you need to create the SQL that's going to be embedded in your programs to communicate with the database backend. Okay? All right. let's jump ahead a little bit more. Okay, so throughout the class, we're going to be using one database in particular during the lectures, and you'll also know that there are, at the end of every chapter, there are exercises. And in fact, if you pay attention to the instructions on the downloading of the software from the publisher's website, you're going to get a couple of things. One is you're going to get the code that you need to run to create this accounts payable database on your computer. Two, you're going to get a copy of the answers to the exercises that come at the end of every chapter. So it's going to give you the opportunity to do the exercises as a way to test what you've learned. And then also to look at the provided solutions to the exercises to check your work, or perhaps from time to time to get inspiration. The exercises that I'm going to be assigning you are from another set of exercises that are not in the book. They are available in our weekly schedule, and the solutions to those are ones that I keep tighter control on, although I will be sharing them with you at the appropriate time. So from the lectures and from doing the exercises that are at the end of each of the chapters in the book, you should become very familiar with the accounts payable database. So here what we're seeing is a display, probably from MySQL Workbench. And we're looking at the results of a query in which we have queried the vendors table, which is one of the tables that make up the accounts payable or AP database. And we can see that the columns include a vendor ID column, a vendor name, vendor address 1, vendor address 2, vendor city, and vendor state. And you can also see that we're going off the right side. Implicitly, you can see that there are more columns than we can even see in our current view. And we have rows. Okay, so relational databases are organized in tables. We're pretty familiar with the table concept from our work with things like, say, spreadsheets. Tables have columns and rows. And you can see here that we've got columns and rows. In relational tables, each table has a primary key, which is one of the columns of the table that can be used. Actually, one or more of the columns of the table can comprise the primary key. In this case, it's vendor ID, a single column. And we can use that to retrieve the row that we want. And we're going to learn over the course of the our work within the course that primary keys have to be unique. So in this case, the vendor ID number, you can see for all the rows that we can see, it's unique. It uniquely identifies the row. So if I were to tell you, I want you to find vendor ID 4, you could look at just the slide that we have here and say, oh, vendor ID 4 is for the fourth row. It's for a vendor named JobTrack that appears to be in Los Angeles, California. Okay, so this is just the very beginning of the concepts that we're going to be using. So here are some of the concepts from the book that you need to know. Relational database is a database that uses relational technology, and that's a kind of database that's very, very popular. today and has been popular for a long time. A table um, is a collection of rows and columns. Okay. It turns out that each table in a relational database is typically about one thing. Okay. One one kind of thing in our application world. So the only table we've seen so far is the vendor table, and the vendor table is all about vendors. Um, Vendor tables have columns and rows. Each of the columns represents some attribute, some piece of information about the entity or thing that the table is about. So, in case of the column table we've already seen, the columns in the vendor table are a piece of data about a vendor. The rows are about individual instances of vendor. So every vendor that we know about in our system is going to have a row in the vendor table. Not 0 rows, not 2 rows, 1 row. One of the things that we use, one of the terms that we use a lot in spreadsheets is we use the notion of cell as being the intersection of a row with a column. And although we don't use that term a lot in relational databases, we do use it sometime. And that's what we're going to be talking about if we use the word cell. The primary key is a column or combination of columns that have a unique value that uniquely identify each of the rows in the table. Okay, in the table we just saw, vendor ID was a single column primary key. It's possible to have a primary key that's made up of more than one column. And that's when a single piece of data does not uniquely identify a row. And we're going to learn about composite primary keys, and that's what they describe. We also have non-primary keys. Okay, so it may be true that certain other columns might also uniquely identify each of the rows, in which case we've got competition for what's going to be the primary key. Okay, we're going to have a term called candidate key when we're going to look at the table and say, well, what are the candidate keys? And we're only going to pick one to be primary. But it's often important to realize that some other column or combination of columns can serve as an alternate key, in which case they would have to be unique as well. And you should also know about the term index. Relational tables can get quite big. So we're looking at that vendor table. Let's go back and look at the vendor table. We're looking at 12 rows right there. But if you were to look at all the data in our AP sample database, we have, I think, a couple hundred vendors. We have at least 100 vendors, somewhere between 100 and 200 vendors. And that's actually a small table. You know, the vendor table for some big corporation, well, it could have a couple thousand vendors in it. Okay, so coming back here, how does the relational database management system, how does it find the way to the row that we want? Well, you can think of all kinds of ways to do it. Okay, the first thing to know is that the the table rows are not kept in any particular order. Now, when we saw the table rows in our last slide, we saw that they were in some order. They were in the order of the ID. But the underlying technology keeps the rows in an arbitrary order, and it keeps an index. And what's in the index? Well, it has all of the keys, all the primary keys. The primary key index has all the primary keys, and the number of the row in which you're going to find the data associated with that primary key. This allows the relational database software to go through a table and search for things much more quickly than if they had to read the entire table every time they wanted to retrieve some data for us. So in MySQL, which is where we're going to be doing our work, every table has a primary key, and there's an index for every primary key. There's a primary key index. If we have other fields that we want to search on, we're going to learn that we can actually create indexes on those fields too. And that's going to allow the relational database management software to search for rows in the table more quickly than having to scan over the entire table. Because I've, just to give you some idea, I've taught some classes at places. I'm thinking of one credit card processor where they've got databases with tens of millions of rows in one table. So you definitely wouldn't want to scan through that entire table to find what you want. You'd be scanning a long time. Now, the databases that we're going to use in our course are considerably smaller than that. Okay, but the need for indexes is really important as soon as you begin to scale the application up such that the tables are, some appreciable size. Okay, now on slide 16, this is the first time that we see that our tables have relationships between each other. And this is not unique to relational database technology. Historically, I mean, I go back a long time, we would save our data in files, just sequential files. So we would have a file for vendor data. We'd have a file for invoice data. And our programs would put a lot of effort into matching up those two files. Well, now, with relational databases, we put our vendor data into a vendor table. We put our invoice data into an invoice table, and we coordinate them with each other. Okay? And how do we do that? Well, we use these things called keys. Now, if you look at the top of the two tables here on the slide, that's our vendor table. And so you can see the primary key is vendor ID. And so if you have a vendor ID, you can get all the other column values for that row just by looking it up with vendor ID. Well, then in the second block that we have on the slide, this is a subset of the columns that we have on our invoice table. Well, actually, it might be all because the invoice table is pretty summarized. And what we do is that we keep a vendor ID column in order to point to the vendor who's associated with that invoice. Now, I do want to point out here that this is an accounts payable application. So this is not a case where it's our company sending invoices to other companies in order for us to get paid. No, our company has bought some product or service from another company and they've sent us an invoice, and the accounts payable system is what allows us to control the payment of invoices to our suppliers. That's why we've got vendors in this instead of customers. Okay? So each invoice is an invoice that we have to pay eventually. And let's see, we have the invoice ID, that's the primary key for the invoice table. We have the vendor ID, that is what we call a foreign key. So it points to the primary key of the vendor table. Well, this becomes really powerful, okay? Because this allows us to formulate queries in which we can ask for a combination of the data that's in the invoice table and the data that's in the vendor table, and the answer set that we will get back will have them very nicely combined with each other as though we had a custom table that had exactly those columns in it. But that's not the way we store the data. We store the data with every table is about one thing, okay, or one entity. So the vendor table is about just vendors. The invoice table is about just invoices. And tables contain these columns called foreign keys that allow us to relate data from one table to the data in another table. We're going to be learning a lot about that throughout the semester. So, terms to know. Foreign key. A foreign key is a column in a current table, the table that you're in right now. It's not its primary key. It's one of just the data columns. But it has a special quality because it holds a value that points to the primary key of another table. Okay, so it allows us to build a relationship to that other table. We have this thing called referential integrity, and that says if we point to a row in another table, that table had better be there, and that row had better be there too. So if we're in the invoices table and we point to vendor ID 12, then there had better be a vendor ID 12 in the vendor table. If not, we have broken something that we call referential integrity. Modern relational database management systems have the ability to tell the product that you want it to force referential integrity, so that when we're inserting new rows into tables, or we're deleting them, or we're updating them, the relational database management system will make sure that we don't break referential integrity. Now, the relationships between tables can be one-to-many, or one-to-one, or many-to-many. And this has to do with how many rows in one table relate to how many rows in the other table. Okay? So one-to-many kind of makes sense. In fact, we have one here. If we go back to slide 16, we'll see that we've got several invoice rows that are associated with vendor ID 1, 2, 3. We've got 1, 2, 3, 4, 5 of them. So that's a classic one-to-many. Okay? one of the interesting things that will point out now, how do we make a one-to-many relationship work? Well, we take the table that has the many, and we have each of the rows point to the row on the one side. So you can see the table that has the many is the invoice table, okay? And we have 5 rows that point to 1, 2, 3, Federal Express Corporation. And so it's the many side that points across to the one side. One-to-one, we're going to learn about one-to-one, but we're also going to learn to be a little bit suspicious of it, because if things have exactly a one-to-one relationship, then aren't they exactly the same thing? So we'll have some one-to-ones, but we're going to be a little bit skeptical of them. And then many-to-many is actually a relationship that you can't make work directly in relational databases. And we're going to find out that we're going to take many-to-many relationships between tables, and we're going to have to break that into 2 relationships that are one-to-many. But that's getting way ahead of ourselves. Okay, so when we are looking at these tables, we're going to be able to get information about them. Here's kind of a screenshot from MySQL Workbench, where we're looking at some detail on the invoices table. And among other things, we see a list of the columns. So it begins with invoice ID and vendor ID, blah, blah, blah. We find out that each column has a type. So there's a data type, and the data that you put into that column for a particular row has to conform to that type. Then we've got a bunch of checkboxes. The one that's the most important to us so far is the PK1. That identifies the primary key. And because there's only one primary key, although I could take this back, your primary key can actually consist of more than one column. So I guess if we had a primary key with more than one column, we would have the PK box check for all of them. Let's say it was made up of 3 columns. The rest of the boxes, let's see, PK is primary key, NN is not null. It means it always has to have a value. UQ is unique. B is it's a binary type. And then we go on and on and on from there. Okay, so we're going to be learning about all those properties in a later chapter, but that's how you might explore information about a particular table. Here are some of the data types. The character types are, I will say that they're char and varchar. Okay, now most people say char and varchar. I just want to say, if it was really char, wouldn't they be characters? Okay, so a character field is a char field is a field of fixed length of characters, like char 25 for a name. A varchar is a variable length character string with a maximum. So a varchar 25 would hold from it would hold a 0 length empty string up to 25 whole characters. The numeric types that are most popular are int and decimal. We would use the int for things that we count 1, 2, 3. We typically would use the decimal for amounts of money, $25.39. The float gives us an opportunity to have a floating point number, which is another kind of a number that can have a fractional part. But you have to remember that there's a lot of rounding that goes into floating point numbers, and there are a lot of us, including me, who think that floating point numbers are not sufficiently robust for dollars and cents. And people like me will point you to the decimal for dollars and cents. And then, for instance, we have a data type for date, um, uh, which we're going to learn about throughout the course. So some terms to know. The data type, every column has a data type, and the values that are going to be assigned to a particular row for that column have to conform to the data type. Null value, this answers the question, what will we get if we don't give any input for that column, for that row? Well, the answer is you get a special value called null that says this is empty, okay? One of the things that we can say when we set up the rules for a table is we can say this column cannot be null. So if we do that, then the database management system software will not allow you to create a new row where that particular column doesn't have a proper populated value. It can't have a null. If you don't have that requirement, it can have a null. The difficulty with nulls is often this: it's often to know what they often hard to know what they mean. So at a minimum, um, uh, it means I did not provide you with a value. Okay. It might mean there is no value. It might mean there might be a value, but I don't know it. It might mean there is a value and I don't know it. So null values are problematic, and we actually try to control them for the reason that they create a lot of vagaries in the data that diminish its overall value. We can have default values. So we can say if no other value were provided for a certain column, that it would get a default value of 10. And we can also have these auto increment columns. These are really helpful for things like invoice number and that kind of thing. Not so much in accounts payable, because we can have all kinds of invoice numbers there. But let's say we're generating invoices ourselves, and we want the first one to be 1 and the second one to be 2 and the third one to be 3. We can also, we can say this column is going to have the type int or integer, and it's going to auto increment. And so we're going to make sure that we create only one of each of the numbers. And we're going to be learning about that. Now here on slide 21 is an entity relationship model for the AP database. AP, again, is accounts payable, and this is the sample database that we're going to be using for the lectures and for the practice exercises, the ones that have the answers available to them. You will notice that some of the things that I've been saying so far are really borne out with the diagram. So this is an EER diagram. It's an extended entity relationship diagram. It's a kind of a diagram that is drawn by a piece of software that we're going to be using called MySQL Workbench. So that's the reason why we're showing you this exact kind of diagram. Entity relationship diagrams of some kind are kind of the standard way to show the design of a relational database. So the rectangles with rounded corners here, they represent the entities in our problem space. So if you look at the problem that we're trying to solve with accounts payables, we have vendors, we have invoices, we have general ledger accounts, we have invoice line items, and we have terms. Okay, so let's just kind of walk our way around here a bit so we know our way around. So again, these are invoices that are being sent to us for stuff we bought. Okay, so every time we buy something on credit, for instance, somebody's going to send us an invoice and expect to be paid. So that'll be a new row in invoices. Okay, now it turns out that in our accounting system, right, um, we have a bunch of general ledger accounts. The general ledger is a series of accounts that we charge off our expenses to. And on the expense side, we also have a series of accounts that we use on the income side. Now, it turns out that in our system, you can have an invoice that is charged in part to one account and in another part to another account. So, for instance, we might charge one account for raw materials and another account for transportation if we paid to have it shipped. Or maybe sales tax would be a separate account. So the only way we can do that is or the way that we do it in a well-designed relational database, is we associate these invoice line items with the invoices. So here's where we begin to read these lines that go between the rectangular boxes. These are relationships. So here's what we're saying, so that for every invoice, we have one-to-many invoice line items. This notation on the line that goes between them, the single slash is a 1, and then the crow's foot is a many. And then if you read it in the other direction, you say for every line invoice item, we have one and only one. That's how you read those two single slashes. We have one and only one invoice. Okay? So if we have a simple invoice, we're going to have one row in the invoice table and one row in the invoice line items table. If we have a more typical invoice where we're charging off to say 2 or 3 different accounts, then we're going to have one row in the invoice table and maybe your 2 or 3 line item rows. Okay? Now each line item row is going to be associated with one and only one general ledger account row. And if we turn around, we can say each general ledger account row could be associated with, and this says one-to-many invoice line items. And I just want to say that we may have a lot of accounts that don't have any line items associated with them at all. So this is kind of technically incorrect. It should say 0-to-many, in which case it should say circle crow's foot. But we'll get to that later. And let's go through the rest of these. For each vendor, if you look through the design of the database, there is a default account that we're going to charge their invoices to. This, I think, is really just there so that in our web application for this, when we prompt you to say what the account is, we might give you an interesting default. You know, you might look at that and go, oh, that's just the account I wanted. Okay, so each vendor is associated with one and only one default account, and each general ledger account is associated with, and here it should say 0 to many vendors, because we could easily have some accounts that aren't associated as the default account of any vendor. Okay, let's look over at terms. What are terms? Well, in accounts payable, people give you terms. Typically, they expect to be paid in a number of days. So typically they talk about net 30, which means they'll send you the invoice, and if you pay within 30 days of the date of the invoice, you only have to pay the face amount on the invoice. Okay? Sometimes they'll give you a discount for early payment. Sometimes they'll charge a penalty for late payment. Well, these arrangements are called terms. And we have a table of terms, standardized terms, where each row has a terms ID, which is just the key, and a description, which is a varchar 50, and term due days. I don't really understand how they use that. It would seem to me that's kind of redundant with the description, but who knows? So here's a kind of interesting thing here. So every invoice has one and only one set of terms. Okay? One set of terms could be associated with, again, it should probably say 0 to many invoices. Okay? So why is there a relationship between vendors and terms? Well, the same way there was a relationship between vendors and general ledger accounts, they want to have a default set of terms. So again, in our application, when we go to put the terms in, it's going to prompt us with what we think the terms are probably going to be to make the data entry even easier. Okay, so for each vendor, we have kind of guessed ahead at what's probably going to be the general ledger account and what's probably going to be the terms. Now, when we get to the invoices, we'll put in the real data, but this is just sort of a hint ahead to make the data entry easier. You will notice, if you really think about this, that that we haven't stored any redundant data except for these things that we call foreign keys. Well, how so, Kevin? Well, let's look. On the invoices, when we want to have the vendor information, instead of putting down the vendor name, the vendor address, and all we do is we just have the vendor ID. If you want the details for the vendor, you have to chase the relationship across and look in the vendor table. Okay? Likewise, if you want to know what the terms are, well, we only give you the terms ID. If you want to know what the terms are specifically, you have to chase it across into the terms table and retrieve the row that's appropriate. It's the same thing for okay, so those kind of things, we're not keeping duplicate information. Okay, then for each invoice line item, each of those is associated. How about that? Each of those is associated with a general ledger account. Okay. Well, what's the description of that general ledger account? Well, you don't know from this table. You have to take the account number, which is a foreign key, and chase it over into the general ledger accounts table. So what we're going to be learning how to do is we're going to learn how to use a set of tables like this that have all the redundant information squeezed out of them except for these foreign keys. Now, for some of this is going to be easy, and for some of us it's going to be hard. But this is how we do things with relational databases. One of the nice things about this course is that we're not going to have to design a relational database until towards the end of the course. So by the time that we have to come up with a design that meets with these principles of no duplicate data and each table being about only one thing, by the time we get there, we'll have had a number of weeks of using a well-designed relational database. And it's sort of the point of view of this course and the courseware that we're using that it's a lot easier to learn it after you've been using a well-designed relational database than if you do the database design stuff first. Okay? So that's the database we're going to be using over and over again during the lectures and in the practice exercises. Slide 22, relational databases have been around since 1970. So they've been around for, I'm recording this in 2016, they've been around for 46 years. Okay. Really useful database products arrived in the early 1980s. So products like Oracle, products like IBM's DB2, products like Microsoft SQL Server were in the early to mid 80s. The product that we're going to be using, MySQL, came to be in about 1995. The most interesting thing about MySQL is it was a free database, and even though it's been bought by Oracle, it remains a free database. Now you can buy a pay version and get more support, but the version that we're going to be using for learning is free. And here's a little more of the history of relational databases. Now, a couple of the events on the history have to do with the SQL standard from the ANSI organization and or the ISO organization. And we can see, for instance, here in 2003, there was an ANSI published standard SQL4. Now, I just want to point out that there's a standard for SQL, and all of the vendors support a particular version of that standard from a particular year, and plus they have their own add-ons. So with MySQL, as we're learning it, we're going to try to identify, we're going to try to teach as much as possible the standard SQL, okay? And from time to time, we're going to learn about a specialized MySQL only feature. So how does knowing standard SQL help you? The basic SQL statements are often the same dialects. Once you know one, you can easily learn others. How does it not help you? Most applications require modification when you move to another database product. So the strategy is to use the standard MySQL statements as much as possible and to use as few of the proprietary features from the product that you're currently using as possible. And you're never going to get to the point where if you convert from one product to another that you're not going to have to do any conversion. But what you're trying to do is to make that as easy as possible. Here on slide 25 are the first releases of some very popular products. So Oracle in 1979, MySQL in 2000. And here's when they became available on, and here's a list of the platforms that they're currently available on. One of the things you can see is that most of the products are available on most of the operating systems. So even MySQL is available on Unix, Windows, Mac OS, and the IBM mainframe operating system, ZOS. And for the most part, that's true on all of these. Okay, so a pretty wide availability of relational database software products. Now, earlier I was talking about SQL queries, and when we talk about SQL queries in the general sense, we're really talking about any SQL statement. When we're talking about them in the specific sense, we mean the select. So we have a bunch of statements that we use to retrieve information from the database that begin with the keyword select. Okay? The other keywords that we have, insert, update, and delete, well, the insert is how we initially add the data to the database. The update is how we update it, and the delete is how we delete it. Generally speaking, you can hear people call these all queries, but it's really the select that is the query per se. All four of those are called DML statements. They're part of the SQL that comprise the data management language. And those are the instructions that we use to, again, to query, to insert, to update, and to delete. We also have a part of the language where we are setting up and defining the database, and that's called DDL, Database Definition Language. And DDL statements include create database, table, and index. So that includes create table, create index, alter table and index, drop database, table, and index. And we're going to be learning about all these. So here are some examples of some of the SQL statements that we're going to learn about. So to create a new AP database, we're going to have create database AP. To say that we want to work with the AP database, use AP. Okay. If we wanted to create a new table called invoices, we would use a create table statement like the one we see on slide 28, and you can see that it's really getting a lot of details about the columns, whether they're primary keys or not, whether they can contain nulls or not, what their data type is. And then we even finish up with some constraints having to do with foreign keys. Here are some more SQL statements we're going to learn about. Alter table invoices, add balance due, blah, blah, blah. We're taking the invoices table and we're adding another column to it. And it's a decimal column with 9 positions of accuracy, 2 of them being to the right of the decimal point. If we want to delete the new column, we could say we want to alter table invoices and delete and drop that column. if we want to create an index on a table, create index, etc. If we want to delete the new index, drop index, etc. So this is our invoices base table. Again, this is not the whole table. This we see most of the columns here and only the first 5 rows. How do we get real useful information out of our database? Well, using the select. Now, those are the things that are queries in the narrowest sense. So this is where we get the real payback. So here is a select that retrieves and sorts selected columns and rows from one table. Okay, so we select, we name the columns, from, we name the table, where, we name a condition that's going to limit the rows that are going to qualify, and order by, we talk about the order that we want the answer set in, or the result set. And what we see at the bottom here is the result set. So these are the columns that we asked for. These are the rows that qualified. Now, it's going to be more typical that some kind of answer that we want that's going to have this kind of robustness that our users are going to demand from us is going to require a query which takes information from 2 or more tables and joins them together. So here on slide 32, we have a select that joins the data from the vendors and invoices table. And as you can see down in the results set, we have vendor name, invoice number, invoice date, invoice total. We got that from a combination of the information in vendors and invoices. Terms to know. Query. Well, a query in its narrowest sense is an SQL select statement, although you will hear people use it to refer to the insert, the update, and the delete as well. The base table is just the table that we are retrieving the data from. The result table or the result set, one of the really neat things about relational database technology is the data is kept in tables, and when we get the results of a select back, the answer set is always a table itself. And this has some particular power that we're going to learn about and experience throughout the course. Calculated value, we don't have to store information in the table that can be calculated from other information in the table. So one of the things that we're really going to do when we design these relational databases is we're going to have really tough standards for what we store and what we don't. We don't want any redundant information. And so we typically will calculate anything that's calculatable and not store it in the database as redundant information. Join. A join is one of the key words on a select statement that allows us to get a result set that includes data from more than one table. And there are inner joins and there are outer joins. And in inner joins, we're going to learn that all of the data has to match and be in the tables. And outer joins, it's possible for one of the tables to not have a match. And it's kind of hard to describe that without the use case. So probably good to remember there are inner joins, which is your average join, and outer joins, which is your unusual join that we're going to learn about when we get to it. As I mentioned before, there are parts of the DML that are not queries per se, but they're very important statements. So the insert is how we insert rows into tables. So here we have an SQL statement that inserts into invoices, and we name the columns that we're inserting into, and then we say what values we're going to put into it. Okay, so that's how we get a new row in the invoices table. How would we change the value of a row? Well, we would use an update. So here on the top part of the slide, update invoices, set the credit total equals $35.89, where invoice number equals, and then we have invoice number. Or we might want to do updates on a bunch of invoices. So here's a statement that changes the values in invoice due date for all invoices with the specified terms ID. Okay, so we don't have to only have to update one row at a time. On slide 36, on the top part, a statement that deletes a selected invoice from the invoices table. So here is a delete from invoices where we identify a particular row. And then the lower part of the slide is where we are deleting all paid invoices. So we're going to delete more than one row. So you can see that this SQL can be pretty powerful. We can do things a row at a time, or we can do more than one row. So it's a very powerful language. Slide 37 is all about formatting. Okay. In the example on the top, we have everything in lowercase, and we're not really using any indentation. On the example that's on the bottom, we have essentially pretty printed the same query, and we've probably used a feature that's available in MySQL Workbench that I'm going to be showing you in the next of our chapters that will put this thing into a pretty useful format. The keywords like select are put into all caps. The names of the columns and such things, and the names of the tables are put into lowercase. And there's some kind of standard indentation that's used. It makes it a lot easier to use a lot easier to read the query. We have comments. So those of you who have worked in programming languages of some kind before, you'll know that it's a pretty good practice for programmers to add comments to their code to leave metadata about the code around. So here in the top example on the slide, we're leaving a multi-line comment, which is called a block comment as well, and it begins with a / asterisk and ends with an asterisk /. And here's where we find out that the author of this was Joel Murach, who is the author of our textbook, and we have a date. The second example on the slide shows us the format for a single line comment. It has a -- so after the -- everything else is a comment on the line. So whether you use a single line comment or you use a multi-line comment, this is a great way to leave behind important information for those who are going to maintain our code. So slide 39, we've got some recommendations for how to author our code. Capitalize all keywords. We can do that with our Pretty Printer. Use lowercase for the other code. The Pretty Printer will do that for us. Separate the words and names with underscores. We can't use dashes, and so we typically use underscores. Start each clause on a new line. Break long clauses into multiple lines. Indent continued lines. Use comments only for code that is difficult to understand, so don't overuse comments. Make sure that all comments are correct and up to date. Note, line breaks, white space indentation, and capitalization have no effect on the operation of a statement. So most of those things that have been recommended here are things that will be implemented by the pretty printing features of MySQL Workbench, or they are practices that we'll be following throughout the book. So if you follow along, you're going to be able to follow these guidelines quite easily. Here we get back to system architecture. Okay, we just wanted to show you an example of code that uses MySQL statements. Okay, and you'll remember that there are two groups of people who are likely to be taking this course. People who at some point are going to become a power user. So they're going to learn how to use exactly the tools we're using in the course. They're going to be using MySQL Workbench to type in the queries and to execute them. And they're going to be using MySQL Community Server to execute the queries and send back the result set to Workbench. Okay? Now, what if you're part of the other group? What if you're an application programmer who has to learn how to include SQL statements inside of application code? Well, this is the group that we're talking to now, okay? Nearly every programming language, and this includes the ones that for modern three-tier client server, where most of the work is being done on a web application server, and also early client server architectures where most of the code is run on the client. In whatever the programming language of preference is, it typically has an interface to the relational database product that you want to use. In the case of MySQL, we're showing you three situations here. One is where you have a web application that's written in PHP. The other is you have some application that's written in Java. And the third is you have some application that's written for the Microsoft platform with C#. And they've got a couple of layers of application programming interface, but down at the bottom, they all send their requests to the MySQL Community Server, and they all get the answer back from the MySQL Community Server. Two commonly used MySQL drivers. Connector J is used for Java. Connector Net is used for Microsoft.NET. Terms to know: Data Access API. Those are the calls that you use to use the API. Here are a bunch of, in a row here, there are 4 products that allow programming languages to communicate with the MySQL database server: MySQLi API, PDO API, JDBC API, ADO.NET API. And database drivers, typically there is a piece of software that sort of acts as the common communication thread between the database server and the application programming language that you've chosen. So here's just on slide number 43. Here's how in a PHP page that would be running on a PHP web application server, here's where we would put a query, a MySQL query into the PHP code. Okay, it just goes right into the code. All right. And here on slide number 45, here's a Java program. Now this is a pretty simple Java program that I think is running just at the command line from what I can see here. And again, we are defining a string called query, and it's going to hold the text of our SQL query. And in both cases, in the PHP case and in the Java case, the text of the query is really pretty much the same text that we would have used if we were typing it into MySQL Workbench as a power user. So the kinds of queries and other SQL statements that we're going to be learning in the course are going to be as useful for programmers as they're going to be for power users. And a little more Java code. And that's it. So whether you intend to be a power user or whether you intend to be a programmer or both or either, this is a course for you. Okay, we're going to learn the MySQL statements that you need to do all the things that we saw within the chapter. You're going to get the chance to run them and to make them work and to hopefully have a lot of fun doing it. And with that promise, I'm going to leave you until next time. Bye-bye.